I'm going to show you how to use Arduino, in this case an Arduino Uno, to program an AT89S52 microcontroller. That's an Atmel microcontroller, but one that runs the old 8051 code. So for this demo I'm using this, it's actually called an EC1204B clock kit, although it goes by other names as well, such as rotating LED clock kit. But the important thing is that it's got this AT89S52 chip on. So you can see it's being powered from the Arduino and connected to the Arduino. So you have to connect VCC and ground to power it, and then you connect the ISP program, the normal wires, which I've got a little sketch here. So you've got it uses pin 10 of the Arduino to connect to the reset line, and then MOSI, which is master out slave in, connects to MOSI, and MOSI is available on the ISP connector on the Arduino, but it's also pin 11. And then similarly you've got MISO, which is master in slave out, pin 12, that connects to MISO. S clock, or SCK sometimes, which is the serial clock, and that's pin 13 on the Arduino, and that connects to SCK. And then, as we said, 5 volts on the Arduino to power it, goes to VCC, ground goes to ground. So to program it, I'll start with Windows, because I know that's what most people use, but later in the video we'll have a look at Linux as well. So the first thing is to fire up the normal Arduino shell, ISP I should say. Hopefully you can see that. I'll zoom in a bit so that you can see it on lower resolution. So you can see I've got a sketch here called Arduino ISP underscore AT89S52, and there's a link to this in the description, but it's actually a very slightly modified version of one of the built-in examples. So if you go to examples, what's it under? Arduino ISP. Sorry, Arduino ISP. There it is. It's open, that one, and you'll see it's almost the same thing. All I've changed is I've switched off the flicker. I think there's a thing called flicker which makes some LEDs work and slows it down a bit, and I've changed the baud rate. So you can do it yourself if you want to, but it's a standard sketch. So we're going to upload it to the Arduino in the normal way. So we've got tools, we've got board, Arduino Uno, and you can see on my computer it's on COM11. We'll need to know that later. So I'll now go and upload it in the normal way. Click on the little upload button, and down there it's compiling, and it's uploading, and it's finished. So that's the first thing. Well, connect it up and install that Arduino sketch. Now the next thing is we can close the Arduino IDE down now, and now we're going to open we're going to open the File Explorer, and we're looking at local disk C. You can put this folder anywhere, but let me just get the camera set up so we can see what we're doing. I've created a folder just on drive C called AT89S52. If the camera would focus. There we go. So I'm going to hold down the shift key. Oh, I'll show you what's in there first. So all that's in there is we've got AVR Dude, which is the standard file that comes with Arduino IDE. I'll get rid of that reflection. But I've put a copy in here, save you finding it. We've got a different avrdude.conf file. That's different to the standard one that comes to Arduino, but that's why it's in this separate folder, so it won't upset anything. And we've got a couple of hex files that we can eventually download to the AT89S52 chip, and we've got a couple of batch files to save having to type in some long commands. So I'm going to go back up a level, and I want a command prompt, or as it's called on latest Windows, PowerShell. You can use either. If you hold down the shift key, I mean, get to a command prompt or a PowerShell, however you want, but this is one way of doing it. Hold down the shift key, right click, and you see one of the choices is open, sorry for the jerky camera work, open PowerShell window here, and it's actually put it over there, but we'll just move it around so we can see what we're doing. I'll make it a bit smaller and try and get it so you can actually see it. Looks as though the blue is even harder for it to focus on than the I'll get rid of that reflection. That'll help a bit. Right, so if we do dir, we can see a directory just the same as we saw before, and what we're going to use is this this batch file called writechip.bat. So if you were in an ordinary traditional Windows command shell, you'd just type in writechip.bat, but on PowerShell you have to put /writechip.bat. Capital C, isn't it? Capital C. If we just do that, it'll tell us what it expects. So it wants us to tell it the port, which, if you remember when we were in the Arduino IDE, the Arduino is connected to COM11, and the name of the hex file. So I'm going to send it one called pattern.hex. I think you can see there. It's a little test pattern. So I'll just move the camera again, sorry if it jerks. So we're going to say writechip.bat, and we're on COM11, and we're going to send pattern.hex. Move that so you can see a bit more of it. And away it goes. It fires up AVR Dude, and you can see there's a sort of progress bar there, and that's writing it, and then it reads it back to verify it, and you can see it's finished. So we now got a pattern running on the clock that we didn't have before. So this pattern just moves those LEDs around the edge in sort of 3 steps, and on the display it counts up to 100. So now we'll upload the real clock sketch, which obviously it's bigger and will take longer. When this finishes, it just wants you to press any key, just so you get back to the command prompt. So same again, but this time I'm going to send it clock.hex. So you can see that's, perhaps you can't see, but it's only done 10% so far. But if we look at what the Arduino's doing while that's going, you get both the read and the write light up on the Arduino. There's those two orange ones on this Uno, a bit overexposed. You can't see anything happening on the clock kit because it's still sending it. So we're about 57% done now, 60. I'll just show you back on the screen. And when it gets round to doing the verifying, we'll look back at the Arduino again, and you'll see the lights go out when it finishes, and the clock program will start running on the thing. So there we are, it's verifying now. Verifying is quicker than reading, so you can see it's still verifying at the moment. When the orange lights go out on the Arduino, the program should start to run on the clock kit. And there we are. So if I just show you what the clock kit can do now. So there's the time, 1854. You can see the seconds moving round. It's just gone 1855, and that is correct. If I show you my that's internet time up there. The temperature's wrong because that temperature sensor's up near the computer, so it's reading 2 or 3 degrees high. But you'll see in a moment we've got a temperature sensor on the clock as well. So we've got 1855 in 24-hour mode, and if you've seen the other videos on this, you'll know that the this default display on this, the group of 5 LEDs that aren't moving very much, that indicates where the hour hand is, so about, it's coming up to 7 o'clock. The group of 3 LEDs at the edge is where the minute hand is, so it's about 5 to 7, and then the single LED moving round is the seconds hand. If I press the button, so that was 24-hour mode, that's 12-hour mode, that's the month and day of the month. I've also now made it read the sensor, so the temperature sensor, so we can have 29, that's centigrade. We can also see it in Fahrenheit. Just to prove that the temperature sensor's working, I've got a can of freezer spray here. So if I hit the temperature sensor with some freezer, we should see the temperature go lower. We're down to minus 23 Fahrenheit now. Just come around and show you some of the other. I'll come to the music in a minute. We can also see it in centigrade, so it's still minus 26 centigrade. Now you heard the music start to play there. If you press the other button in the normal running mode, it plays the Mario theme. And in this mode it doesn't show the hour hand and the minute hand. It shows sort of the note. You see high notes are up near the top, low notes are at the bottom. I suppose normally when you're doing this you'd want to see the time, because you can still see the time on the 7-segment display. go back to the Fahrenheit one. You see it's warming up now. It's got to get up to about 70 odd, I suppose, is the current 70 or 80 is the current temperature. We'll let this music cycle all the way through so that you can see how long it plays for. Let's put my finger on the temperature sensor to warm it up a bit. That's it, the music's finished now, so it's cycling over again. I'll just stop the music, go back to the clock display. If I can find the right button. That one I think it is, yeah. There we are. So that's about it. Oh, now we've also got a batch file to read the current contents of the chip. So if we do the same thing with just put in read chip instead of write, I've got to press a key to continue. So if I change that to read chip, and change that to contents, so that'll read out the current contents of the flash memory and store it in a hex file called contents.hex. There we go. That's assuming that whoever's programmed the chip hasn't. You can enable some fuses that prevent the chip from being read, but the kit as delivered actually wasn't protected. So before I reprogrammed it, I downloaded the original contents, and they are in this folder as well. So if you want to go back to the original clock software as it was delivered, as I say, if I do dir now, dir, I say you've got those folders, those files we said, we've got AVR dude and so on, and you can see there's the contents.hex is the one we've just downloaded, and then you've got original clock.hex, that was the program as supplied in the clock kit. Pattern.hex was the little test pattern you saw, and clock.hex was the new one I've written with the music. Okay, so Linux instructions to follow. Okay, so here we are in Linux Mint, and if I open the Arduino IDE, it'll probably open up on the other monitor. I'll wait patiently. I've only just started the PC, it takes a long time to start up the first time. So we want to open the Arduino ISP, which is that one. So obviously it's exactly the same as on the Windows version. Seem to have some fringing there on the screen, but the only difference is that obviously the COM port's going to be different. So on here it's called dev /dev/tty acm0, but you'd compile it, upload it just the same. So if we go and have a look at the home folder, I've got a file there called a folder called AT89S52, and if we have a look in there, pretty much exactly the same as the Windows version, but of course instead of being .bat files, they're shell files in here, and I've called them readchip.sh and writechip.sh. The other file's exactly the same. So if we go up a level and say from the menu, easier than Windows of course, we want open in terminal, and there we go. I'll just zoom a bit so we can see the terminal. So if we say dot, what do we want, dot slash, I can't see the keyboard, oh dear, dot slash write chip. Not a good idea to type in the dark when you're reaching around a camera. Writechip.sh, that'll give us the prompt. So on this one I've made it actually default to the to that port, save us typing in /dev/acm every time. But if you've got a different port, you just put writechip.sh -p and the name of the port and then the file name. So if we send it the pattern, writechip.sh, what was it, pattern.hex, it's just the same as the Windows. It fires up AVR dude. What's it saying? Oh, actually got a, oh, there obviously isn't a file called pattern.hex. What's it called? I've got clock.hex and original clock.hex. I haven't got patterns.hex on there. Let me just go and grab a copy off my NAS. So if we go on there and we want pattern.hex, I want to copy that and paste it in there. Right, now we'll have another go. Let's move the camera so we're down towards the bottom of the window. So we'll just have the same command again and it should work this time. There we are, it's writing. So if we have a look at the Arduino, you can see the lights on. We're about 80% complete at the moment. It's verifying, and there we are, it's finished. So you can see it's exactly the same, and you can read the chip contents as well. So all the files, the Arduino sketch and the Windows folder and the Linux folder will all be in, there'll be links in the description. Thanks for watching.